Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to discuss about a project on property price prediction. Yes, in real estate marketing, accurately predicting property price is crucial for both sellers and buyers. And here today we are going to develop a predictive model for property prices, so that can provide valuable insights into market trends, helping stakeholders make well-informed choice. And dear friends, this exact problem or project or problem statement, whatever you can just specify, this exact project aims to address the challenge of property price prediction by employing regression analysis. By utilizing a dataset containing various property futures, we will build a model to estimate the property price based on key attributes, and the insight from this analysis can assist in making data-driven decision and understanding the factors influencing the property values. And dear friends, I want to specify here, yes, this exact PDF, of course, this exact document, I just include it in the GitHub, and I just share the link to your video in the description or in the first comment. And kindly just have a go through each and every attributes has, if it is a categorical, what are all the categories is there, and of course each and every attributes I have just given here. So kindly just have a look and then get into the project. And of course, this exact document. It's very much important when you just start onto this project. And exactly, dear friends, here I have just specified what is the learning outcomes of this exact project. And before going on to the project, here I have just specified the what is the exact abstract and towards the problem statement. And let me just dive into the project. Kindly just observe. The same data definition I have just given here. And of course, how this exact project flow is going to be. Kindly just observe, dear friends. See, actually here in this step-by-step guide, we will explore the process of building a machine learning model to predict property sale price. We will begin by examining the data set, performing data cleaning to handle missing values and outliers, and visualizing that is important trend and relationship within the data. Next, we will transform and encode categorical variable and apply log transformation. That is what the main important to our target variable to addresses as like queues and improve model performance. And we will then employ the futures engineering to create new variable which can provide deeper insights into the data and potentially improve our model. We will build and compare multiple linear regression model using ordinary least square method. Various method will be trained, and yes, of course, both with and without log transformation and with newly engineered futures, we will evaluate this model using key performance metrics like RMSE, R-squared and adjusted R-squared value. Finally, we use variance inflation factor to check for multicollinearity and select the most relevant feature to improve model performance. And dear friends, in the end, we will conclude by determining the best model for predicting property prices based on its accuracy and ability to generalize to unseen data. So kindly just don't skip each and every step. It is important. So don't skip it, and let me just watch till the end. Okay, yes, dear friends, the first one, I have given the important libraries, required libraries and functions, starting with the pandas, which is used for data manipulation and analysis, and pandas API, it has been also included, where the function such as isString and isNumeric data type helps check the data types of columns, which is important for data pre-processing and ensuring variables that are in correct format for modeling. And next we have included the Matplotlib and Seaborn for visualization. And next I have included the stats model for statistical modeling, which is a library designed for statistical modeling, that is hypothesis testing and data explorer. And yes, dear friends, it also provide statistical tests as like Spiro for normality and functions for building linear regression model based on formulas. Yes, that is also I have included here. And next we have scikit-learn for machine learning. Yes, which is the tool for classification, regression and clustering and model selection and evaluation. And last but not least, the SciPy, of course, which I have just specified for statistical analysis. Let I just execute it, and yeah, it's done. Okay, now let I just include a few features for filtering the warnings, and next for the figure size, I just keep it with an RC parameter. And yeah, dear friends, next let me just have the display options I have just included for columns of a data frame. Which just ensures that when you view a data frame, all columns will be shown. Even if the data frame has many columns, without the settings, only a subset of columns might be displayed. So I have just specified for number of columns and a number of rows to display all columns and all rows. And last but not least, yes, to suppress exponential notation, which converts exponential value to float. That is also I have just given. So these are all optionals, but anyhow, I have just given it prior to make my options setting it. Okay, now next, let me just have the data to be loaded, and of course I just show you the data. Yes, here which we are having the data, and yes, of course it has more than 1400, at least 1460 data we have. So let me just make use of it as it is in CSV format. I just want to have a look onto the top 5 records here we have. So which it just used to this exact head. By using this, we have just top 5 records, and let me just have a view onto the shape. So as I just scroll down, so here we have the shape, and of course, as I have already specified, we have totally 81 columns, dear friends, and yes, number of records, it is 1460. And yes, dear friends, this exact shape, it just gives us a quick understand about the size of your data set, especially when working with a large data set. And yes, dear friends, so this is the main important point. So data preparation, yes, of course, it is a critical step in ensuring that the raw data is clean and ready for modeling. Here's I have just given through that analysis. We are just going to check the data type, which is ensuring that each column has a correct data type, which is essential for accurate analysis and modeling. And next, we need to change the data type as per requirement if they are not as per business definitions. Okay, so if the data types are not aligned with the business logic or the requirements of the model, they need to be adjusted. And next, of course, we have to review the summary statistics that is provides insight into the central tendency, dispersions, and shape of your data's distribution. And next, it is all about the visualization, the distribution of each variable to understand its shape and spread. And of course, next it is all about the correlation. Yes, analyze the relationship between the numerical variable using a correlation. So this helps to detect multicollinearity where 2 or more features are highly correlated, which can be negatively affect model performance. That can be identified. And of course, identifying the strong relationship between the features and target variables, so which may be useful for model building. So that is what we are going to see there. And next, it is all about detecting the outliers. Yes, of course, dear friends, outliers can distort statistical analysis and predictive model. So it is essential to detect and handle them appropriately. And last but not least, looking for the missing values. So missing values can lead to biased or inaccurate model. So yes, we are just going to look on towards that. So let me just first go ahead with this. Yeah. So what is the data type? Of course, dear friends, we have mixed data types, and yes, in the data preparation process, as I have already specified, it is crucial to ensure that the data types align with the business or data definition. And here I just want to specify one particular thing, the dwell type. So when on just going on towards the dwell type, okay, I just come again with the dwell type here. So kindly just observe here, dear friends, this is the exact one, and here it is just specified as like an integer. It is an integer 64. And one more thing I have to specify when on just scrolling down, kindly just observe, that is overall quality, that is also here it is integer, and overall condition, that is also here it is integer. And however, according to the data definition, these variables are categorical. Yes, kindly just observe. First of all, with the dwell type itself, it is a categorical. Okay, so this exact number, that is as like 20 or 30 or 40, these are all categorized according to this functionality. So it has to be categorical, and here categorical often variables often represents qualitative data, so which can include nominal or ordinal categories. Okay, so that has to be converted. And of course let me just check what are all the things that has to be corrected. So yes, of course, that is what. And overall quality conditions is that. So yes, dear friends, as I have already specified here, I have given you the point that this dwell type, overall quality and overall condition, that has to be corrected to categorical. And of course, here I just added with this categorical. So here to correct the data type, we are just going to make use of categorical encoding. That is, once converted to categorical, you can apply encoding methods with one-hot encoding or label encoding for machine learning model. And yes, this is a betterment when you just if you want to do this, or if you do this conversion, of course you prevent algorithm from mistaken treating them as continuous or numerical variables, so which could lead to incorrect model behavior or insights. So better to change it. So yes, of course, that exact data here we are just going to convert, that is the dwell type, overall quality and overall conditions. Yeah, we are just going to convert that column from integer to object type, and which typically used for categorical. Yes, here we are just making it with as type O, which converts it into the object. And kindly you can just check that now it is converted to object. And here, dear friends, of course, we have just used that as type method to convert the column to the categorical type. And here we just verified, yes, after the conversion, it's good practice to verify that the column have been correctly converted by checking the data types. And next, of course, dear friends, I have to specify one particular thing, the ID column, which is typically unique identifier for each record in the data set, but it doesn't carry meaningful information for analysis or modeling. So yes, we are just going to remove it. Yes, therefore removing the ID column is a standard step in data preparation to avoid these issues and streamline the data for analysis. Okay, now let me just check with yes, these are all the exact data which we are just going further towards the functionality. Okay, so of course we would have reduced the columns, some few columns. Okay, now going on to summarizing the statistics. So, dear friends, checking the summary statistics of all variables in a data set is an essential step in a data exploration process. This allows you to understand the central tendency and dispersion and overall distribution of both the numerical and categorical variable. So first of all, let me just look head on to the numerical data. So here for numerical data, let I just give you. So these are all the exact variables which we just have it as like only the numerical variables here. And kindly just observe, we have the count, mean value and standard deviation, and which we just mainly use to check with minimum value, maximum value, and of course the quantiles. And here towards the quantiles, yeah, we have the 25 percentile, 25th percentile, 50th percentile, and 75th percentile. Okay, so here by viewing this, what we are able to see here is, by viewing this, of course, kindly just observe here when I'm just going for this lot frontage. Yeah, of course we have 1460 data, and here it is specified as 1201. So yes, which it just shows a few data are missing in a few of the columns. Of course we would just handle this in the missing data, and of course I think here only these are the data to be noted. Anyhow, I just scroll slowly. So yes, to be this numeric, yeah, we have this lot frontage and this area. Actually we have a few missing values. And when coming towards this minimum and maximum, yeah, of course the range, value range from 21 feet to 313 feet, indicating there is a variability in the lot size. Okay, and here towards the mean we have 70, so which suggests that while some lots are quite large, many are smaller, which is inconsistent with the observed range. That is what here it is specifying. And of course, since the count of lot frontage, it is less than the total number of observation, this confirms that presence of missing values, as I have already specified. And any other things to be there? Yes, dear friends, of course, when on just checking towards the missing and minimum and maximum data, most of the data here it is with minimum as 0. Kindly just observe this total basement or basement towards this square feet 1, square feet 2, everything here, it just has the 0 as it minimum value. So here also the second floor square feet, everything here we have. So basement full bathroom, basement half bathroom, full bath and half bath, bedroom above the ground level. And here kitchen above the ground level, total rooms, okay, total rooms it is 2. And of course there are so many zeros as the minimum values are here in zeros. So even when we just check for this pool area, here it is specified as like 0. 0 is in the sense the pool area indicates that not all houses in the data set have pools. So this is critical observation since it affects the mean pool area calculation. So we have to be very conscious what is the meaning of that minimum 0. Sometimes the house whichever it is not having the pool also it gives like, and here also the garage cars, that is also here comes under area, garage area, that is also here as a 0. So 0 is in the means it is not as like the value is missing. Of course it can be the house without garage, that also indicates here as a 0. So kindly just be aware of this, dear friends. And when on as I have specified, I also given that here. Okay, now let me just move on towards the categorical data. Yes, dear friends, to obtain a statistical summary of categorical data, we just use include is equal to object. that is describe method, including this object, where we just get it with the count, unique, top and frequency. Of course, here also it just shows that count here. Ajay has an missing data, and so many missings are there here. When considering, of course, here see, kindly just see, it is only in single digit. Pool quality, so that is in single digit, only 7 it is specifying. Okay, so we also have to consider so many things are there, dear friends. So yes, using this functionalities, yeah, we can just observe, and it is understanding that the distribution of categorical data, including how many categories each existing. And of course, when you just see the quality, it has 3 categories. And when coming towards this dwell type, of course, we have 15 unique categories. Totally top, we just has us like 20, which has a frequency of 536 occurrence of records. And here you can just say that is RL zone. So that has 1151 among 1460. So these are all one among the thing. And when coming towards property shape, you can also say here 1460. Among that, 925 are coming under this REG category, and here also 1311, 1459. So kindly just see here utilities in that. Of course, we have only 2 categories. One is AllPub, which has 1459. Okay, so many things we have to include in such a case. Okay, now let me just have, if in such a case, what are all the counts we have. Of course, you can just examine each and every dwelling functionality. So here we have 15 categories is there. Among that, 20, that is 20 is one among the category. I just to show, yes, here we have 20, that is one story with it is a newer all style category of dwelling type. So that has the highest occurrence of 536. So all this gives us an how many observation we have, totally 1460. So from this observation only we are just making this functionality, and let me just have a particular functionalities. Kindly just see here, whenever we just take on towards this single digit calculations and all, and of course I don't think so, whichever we have here, it is not going to make much more difference if we just consider this as an analysis. So here, of course, it is not much more used to. So let me just drop this also. Okay, among 1460, only 7 records are there. So this is not much more used. So let I just drop that data, and of course this pool area also. So now kindly apart from this, finally we have a size of 78 columns. Now what have? Yeah, let me just check for the distribution. That is data distribution. Yes, dear friends, data distribution of all variables in your dataset is crucial for understanding their characteristic and how they relate to each other. And yes, here I just want to check with only the numerical first of all, where here of course towards this numerical variable, here we have, these are the list which we have as an numerical variable. Among the 78 columns, we have only few, and yeah, let me just have it a histogram for each numerical variable to visualize the frequency distribution. And yeah, everything here it is a small. So let I just go towards a particular in effective with the visualization of a numerical variable, mainly on towards the target. Okay, so here towards the target variable, I just check with the sale price towards the frequency and analyze the frequency distribution. So here we have, of course, So this exact histogram, it just displays the frequency of values in specified intervals. Of course, here the bins are provided in very well manner to understand the distribution, underlying distribution. And dear friends, here I just want to specify one thing. If the exact data is distributed, that is having a normal distribution, yeah, a bell-shaped curve indicating that most value cluster around the mean. But here, of course, it shows it is not in a centered manner. So it is not in a bell curve. Of course, there is a positive skew. That is, yeah, most values are concentrated onto the left. And what happens? Yeah, of course, after analyzing this, yeah, let me just look on towards certain values here. I just want to check with that. Okay, I just want to know what is the exact value corresponding towards that certain variables. And here also I just check with the bins. Particularly whether any even you can just check for the outliers. And yes, dear friends, if you are identifying about the skewed distribution, kindly go for a transformation as like log transformation or square root transformation to normalize them. So here what we apply is, of course, we have gone towards a functionality to transform. Before that, let me just have a view on to the categorical variables. Okay, and here towards the categorical variables, I just want to specify mainly on towards the univariant observation, and then we just go for bivariant. And kindly just let me have a view on towards the categorical under univariant. And dear friends, here when on just viewing towards this data, mainly this exact distribution, I want to specify that when we have a loop under functionalities, one second, I just go above and have a view onto this. Yeah, this one. Yes, so here towards this categorical data, yes, this analyzing on towards this, it just provides about the insight into composite of your data and help inform subsequent analysis. Okay, and modeling the decision. And of course, kindly just observe, dear friend, here we inside this loop we have given this df property using this whether it is an string, and here the data type to check if the column is of a categorical type, and then we are making into the sense. And of course, when on going towards the subplot, yeah, we have just created a grid of subplot with 7 rows and 6 columns. Okay, so let me just have the output and let me observe it. So here we are having. Okay, so yes, as I have already specified, we have 7 rows here. So and it is with 6 columns. So yes, this is what. And when on just making towards this analysis according to the categorical, dear friends, kindly just be aware when on just making towards this plotting the way of univariant analysis, it just count the plot that is visually display the number of occurrence of each category in a categorical variable, and which help us to understand the distribution and frequency of each category and within the variable. And kindly just observe, dear friends, when on just making to, even though see actually here you can just say each and every image are very small, and how come we can analyze? You kindly just don't make it in such a manner. So here when on just viewing, kindly just go towards each and every data and observe what we have just specified it. And this exact visualization, it just gives the count plots that provides a clear visual visual representation of how many times each category is appearing, how many times each category it is appearing, and making it easy to identify the most and least common categories. I just give you each and every views here. I just slowly scrolling, so you can just have a view, and kindly just have a comparative analysis. So they allow for easy comparison between the categories, which is useful for identifying imbalances in category futures. And last but not least, you can also integrate with the target variable here. Okay, so here you can just make it towards the target variable, where you can also use the hue parameters in count plot to visualize the relationship between the categorical variable and to the top target. Okay, now let me just move on to the bivariant. So here, when on coming towards the bivariant functionality, kindly just be aware, dear friends, we are going to have property functionalities. Okay, and this bivariant, it just gives you a distribution of visually summarizing of a distribution of here as property sale price across different level of overall quality. And here we are highlighting the medians, quartiles, and potential outliers. Let I just make it here. So this is what the exact overall quality and towards the sale price. And this, it just ensures that both variable here gives us an overview picture. And of course, kindly just observe the median sale price, that is exactly it's providing. So here we don't have the exact image of it, and even though you can just see here, this is the median towards it. And yeah, you can also observe the interquartile range, IQR, and yeah, individual points outside the whisker that indicates the here to be the outliers. And when on just making this comparative, you can easily compare the distribution of property sales price across different overall quality categories. So helping you identify trends such as what is the trend functionalities, or such as whether higher overall quality consistency corresponding to higher sale price. That is also, you can just have a view onto this. Now let we come towards a box plot of overall condition towards the property sale price. We want to see that one particular target, and I just want to examine that. Okay, and towards that overall condition towards the property sale price, kindly just observe here, dear friends, what you are able to have this. And when on just seeing this overall condition, when on making it towards 5, see how many outliers are here, and what about this condition 1, what the exact plot it has. And this will allow you to visualize how different overall condition impact the sale price of this property. So this would give you a good view how you can analyze it and about its condition, and ensure that both this overall condition and this property sale price, it's just creating an amazing information related towards the target functionality. And yes, dear friends, next we are just moving on towards a pair plot. Dear friends, pair plot of this numerical variable is an excellent way to visualize the relationship between multiple numeric futures in your data set. And let I just give here, we have a selected pair plot of this property sale price and ground level area, garage cars, and total basement square feet, full bath, and whether a year built, whether any year remodulation has been added or not. So when on just, of course, we are making it use of a scatter plot, and kindly just observe, we are making use of an density, kernel density estimation also. So here it just provides you a scatter plot for each pair of numerical variable, and of course kernel density for each variable onto the diagonal functionality, which allows you to explore correlations and distribution simultaneously. How come? Wow, superb output we can just able to see. And this kernel density estimations on this diagonal displays the distribution of each numerical variable, providing insight into their central tendency and spread. And when on just making towards this correlation, let I just have a small scroll. So towards this correlation also, it just sees a strong relationship between the variables, and yeah, a tight clustering of point along a line indicates this strong correlations. Okay, so towards this scatter plots, of course, you can just view the identify these outliers also. Of course, see here you can just have an outliers here, here and here. Yeah, there are few more outliers that can be easily identified, and which may require further investigation. Yes, moving on towards this outlier discovery. This discovering outliers is an essential step in a data analysis, as outliers can significantly influence the results of your statistical model and visualization. So let me just have a view of this property sale price. Let I just have a view on towards that alone, and yeah, kindly just have a view, dear friends. And here, when on viewing this, yeah, this exact output, it just shows you what to investigate on towards outlier. Once you identify these outliers, kindly investigate them to determine whether they are due to data error entry or genuine variability or any other causes. And if it's so, if it is decided, if it is dependent on to that analysis, decide how to handle them. And of course, yes, we are just having more than 3.5 of towards this property sale price. Everything here, it seems to be an outlier. Okay, now let me just see how to evaluate it. And here, yeah, we are just going to take it as like whichever it is more than 5 lakh, yeah, we are going to specify it as like an outliers, and we want to drop that. Only the exact shape we are going to keep it is less than 5 lakhs. So let I just make it, and within that, if we have only that records, yeah, we have 1451. What among that make it? Yeah, among so more than a 10 records, of course, we are just removing it, I think so. So yes, of course, here, which is above this 5 lakh, we are just making it remove. So yes, here with this functionality, I just want to check if you are reducing the impact of outliers. Yeah, few more functionalities or further functionalities as like transforming of data as like log transformation or any other transformation we have to apply. Yeah, let me just wait for the further discussion. And here I'm just going with for missing data. Yeah, handling missing data also a crucial step in data preparation, as they can significantly affect the quality of your analysis and performance of your model. And when on just specifying towards the missing, kindly just understand the missing values. I have discussed a lot previously related to how to handle the missing values and how to handle the outliers in my previous sessions or in series. Kindly just go ahead with that data, and when on just making it towards, dear friends, you have to understand whether the missing values, whether it is due to data entry or anything as like equipment malfunctions or anything, kindly just have a view. Even participants not responding to certain questions in surveys, that is also comes under missing data. Okay, and yeah, to check with that missing data, we have functions in those panda functions as like whether it is null, or you can just want to know how many of them. Yeah, you can just make use of this summation also. Okay, so let me just have a look onto how many are there, and let me just have. Okay, so here total number of nulls. So I think few are there, and yeah, here we go with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and yeah, 11, 12, 13, 14, 15, 16, 17, 18 datas are there with the missing data. So let me just have look on towards it. Yes, of course, we have 18 variables that contains the machine values. So with this percentage of missing values, how we are going to handle this? How we are going to handle this is actually it is an essential of ensuring the integrity of your data analysis. So by identifying this, I just want to make it a separation of numerical and categorical data. So first of all, let me just have and handle only the numerical data, because see, actually when you just go on towards this separation, yeah, this numerical and categorical data, you can apply appropriate strategy tailored to that data type. This approach enhances the quality of your data set and ensures reliable analysis and modeling outcomes. So yes, kindly make use of this missing data by using, here I am just going to make only this numerical data first, and here towards this numerical data I just going to apply. So total number nulls, here we have only 3 data is there, and one thing, let me have an applying of median value towards this lot frontage, or you can just specify something value towards any of those missing value, or you can apply mean value here. And of course again we for this another variable we are also having the same median. So kindly just observe, dear friend, for this 3 numerical variables we have applying 2 for median and 1 as an 0, so as a specific data. So yes, here garage facilities, here we are just applying, and to this we are applying for median value. Okay, now let me just go towards the categorical. Of course, I have already specified it towards dear friends. So separation of this categorical and numerical, it is very much important. Where in the numerical you can apply make use of this imputation methods as mean imputation or median or mode imputation, but when on just going towards this categorical, of course you have to make a correlation functionality, you have to make a correlate with other features, and then only you can just apply towards the filling. Okay, and yes, here towards this data on towards total null, I'm just making these values whichever it is greater than 0, and towards this data type I'm just making it as like a object that towards the catering missing values, and kindly just observe, I'm just changing it towards it. So here whichever here we are having, it is I think almost 15 datas we have. That exact 15 datas we are just specifying, even if it is denotes of NA, yeah, it is specified as like a missing. So yes, I just want to fill it with a none, and yeah, for alley I just want to fill it with no alley access. For fence, no fence. Of course, I just want to make it particular towards the category or towards the future which it has. Okay, so that is what here I'm just going to make it. And if every values whichever here related towards garage, yeah, of course some homes or some residents they don't have no carriage also, so I just want to fill it with that particular future as with no carriage. And towards the basement, yeah, let I just give you it as with a basement as like no basement. Okay, and few with none, and of course here also we have imputation with mode value. So let I execute every categorical data corresponding to their futures, and I'm just making it filling. Okay, now everything done. What is that? Yes, let we just go towards the correlation between this numerical variable, computing a correlation matrix and visualizing it with a heat map, which is an effective approach. So yes, we are going to approach it with the correlation. So before that, yeah, this is the exact correlation matrix, and then we have a view on towards the heat map. And here I'm just going it with the map. So yes, here we go with H. Yeah, here it is. And when on just seems to be this data, kindly just observe there is an hard impact here and towards this data. What is the data it is of? Yes, of course, you are able to visualize the correlation matrix with this heat map. And on towards this output, kindly observe, dear friends, here I just go towards this data. It is of total basement square feet and first floor square feet. There is an strong correlation. And here it is of yeah, garage, no, here it is garage cars and garage areas. That has an strong impact. Okay, so this observation, it just gives you an functionality. And towards the diagonal entries, which are all one, yeah, indicates that each variable is perfectly correlated with itself. And when on going towards this strong positive correlation, and of course we have to check with the multicollinearity also. And yeah, when on just checking it with this data, kindly just see here, of course, which I have already specified. There is a strong high positive correlations between this garage area, garage cars, and total basement square feet and first floor square feet, and of course total rooms above the ground level, and of course it is ground area, ground living area. So kindly just have a note. So these are the exact values which we have discussed it. So here the input is, and here we have a positive impact, and here we have a positive impact. So that is what here it is specified. Of course, what we just got, it is already there. And here I just want to specify one thing, dear friends. Correlation does not imply caution. Yes, this exact is a fundamental principle in statistics and data analysis. First of all, kindly just understand what is the principle behind this. When on just going towards this correlation, yes, correlation measures the strength and direction of linear relationship between these two variables. And when coming towards this causation, actually this implies that one event is the result of occurrence of another event. And when going towards correlation, yes, this merely indicates a relationship or pattern between two variables. That is without establishing that one causes the another. So yes, here it is not, it does not imply towards this causation. So yes, if two variables are correlated, it does not mean that one variable caused by the another. Okay, so kindly just have this particular point in your principle to have an effective data analysis. Now let me just analyze relationship between the target and towards the categorical, and here we are going to make use of this box plot for visualizing this relationship. Let me just have, and here we just go with this, And yeah, as I have already specified here, we are just going to have 14 columns with 14 rows with 3 columns. And I just scroll slowly. Kindly just observe this, dear friends. Each and everything, when we just choose a categorical variable, it is actually to identify the category variables which is used to analyze mainly on towards this property sale price. Okay, and this is the what analyze in relation to your target. Okay, and yes, this plotting, this just gives you a clear visual representation of how your target variable relates to the categorical variable. So I just slowly scroll it and have a view each and every data there as an observation. Okay, and kindly just observe about the impact of that categorical variable mainly onto the property sale price, which are all very crucial for understanding the data set. Okay, and yes, here we just go. Okay, now yes, of course we have just done, and we need to have a particular functionality, dear friends. See, future, mainly future are very much important. So the impact of this categorical variable, particularly quality rating, or highlights their importance in predictive modeling. So when building a regression model, it may be beneficial to include these categorical variables to capture their effect on sale price. And of course, when towards transformation also, yes, when that exponential, when we just given that exponential nature of a rise in sale price, yes, that consider potential transformation, that is potential transformation. Of course, I have already specified as like logarithmic or square root or cube for the target variable to normalize the distribution. So especially if you plan to use linear regression or other models techniques, kindly just be aware of this one. And yeah, dear friends, next we are just going for preparing the data. And here, when coming towards this data preparation, mainly check for the normality, which is an important steps in a data analysis, especially if you plan to use a parametric statistical method that assumes a normal distribution. Okay, here's how you can visualize the distribution of your target variable with a histogram or performing the Sparrow-Wick test for normality. Okay, so I have just specified that, and I just apply the main thing. And yes, dear friends, kindly just have a view, look for the shape of this histogram. Towards this Sparrow-Wick test, the data is actually there is a value towards the p-value, and I just want to know what is the exact p-value also. So I just calculate that value, and here you are able to observe. So kindly just have a scroll on towards above. So see here, this one, it just shows observation about the distribution of property sale price, that variable being positively skewed here. That alignment will with common characteristic found in this real estate data. Okay, and when on going towards this positive skew, yeah, the tailed, that is on this right top target value, that is the higher value, is longer or shorter than the left side. Okay, so that is what here. So of course, transformation option is also that. So we are just each and every time I'm just specifying some transformation has to be needed. And when on just making towards that, I want to view the p-values also. So I just have a view on towards the p-value. Kindly just observe the p-value, dear friends. If the p-value is greater than the significance level, commonly set as 0.05, you fail to reject the null hypothesis, suggesting that the data is normally distributed. And if the p-value is less than or equal to 0.05, you reject the null hypothesis, indicating that the data is not normally distributed. Of course, it is already seems to be that it is 0.00, that is less than, okay, and it is not a normally distributed. Obviously, it is shown that, okay, and of course we have that proof in the. Now let me just have a log transformation. From the beginning we are just specifying some transformation is needed, and of course, dear friends, applying log transformation to the property sale price variable that can help reduce skewness and make the distribution more normal. This is especially useful if you plan to use linear regression or other parametric test, okay. And yeah, let me just apply this log transformation, and yes, we have this log transformation, and kindly just let me just have the view. And yeah, here is a brief summary of how to perform this summary of about this log transformation of the data. And of course, here we have so many changes towards the data, okay. So yes, of course, and you can also here we see when on just making towards this log transformation, of course we have used np.log function to transform it. And if there are any zero values in your data, consider using log p 1p, okay, log 1p. Instead of making this log, kindly just make use of log 1p. And yeah, which computes the natural logarithmic of 1 plus x, thus avoiding issues with the zeros. I just let you know that also, okay. Now let me, after applying the log transformation, yes, it is essential to recheck for this normality. So let I just recheck for this normality. Yes, hope how this, okay. Now anyhow let me just have a view of that p-value. So even here, kindly just observe one thing. Even though this exact value, it seems to be as like an bell curve, but when checking on towards the p-value, still it is 0. Still it is in 0. So rechecking of this normality through this visualization and this Spario will test after log transformation. Yes, you can determine if the transformation was effective. If the data remains non-normally, you may consider other transformation or approaches to address skewness further. Okay, so now let we, if the histogram of this log variable appears to be near normal distribution, and but here we have the test how to proceed it with checking with the normality. And even though when on just checking it towards it, kindly just have a view onto the skewness. Yes, we have skew functionalities also. And yes, this exact Spario, we are not getting the exact value to be as like it is an p-value which is less than 0.00. Okay, now what we have to do? Yes, let we consider this functionality to be as like creating and encoding functionalities. Okay, so I just want to make this towards encoding and then go towards the gathering of this data set. Okay, so see, actually it is common for real world data to exhibit characteristics that make it difficult to fully meet the assumption of normality that is required by certain statistical test or algorithm. While visualizing inspections such as histogram and QQ plot, that can provide strong evidence of normality, statistics tests like this Spario can sometimes yield different conclusion, especially with the large data set. So no problem, no problem. So let me just go on towards this numerical values and the categorical values. So let me just make use of this encoding, and we accumulate the data. So we are going to have an future set of our model, and once after encoding, yeah, we are just going to concatenate both the numerical and encoded categorical data here. Now kindly just check for the shape. Yeah, we have 285 columns. As kindly just see here, all the 285 columns are being viewed. How this can be possible? Of course, this is what the exact option which I have just given in the topmost. So this is what. So this is the exact reason how I am just able to view all the columns here. Okay. Now anyhow, let me just apply the data model. Okay. Yes, dear friends. Before applying ordinary least square, yeah, it is essential to make that conversion. So we also made the process of dummying encoding, and here we just got our data prepared for regression analysis. And here, dear friends, it is essential to properly filter and concatenate the numerical and categorical variable after encoding them. So yes, we are very much conscious onto that. And let me just now fitting a linear regression model using ordinary least square. That is what exactly we are going to make the predictive analysis. And we have already summarized the result and interpretations of OLS model very well. Yeah, but anyhow, I just want to give you here what all the things we are going to do. First of all, we would split the data and adding intercept. How we are going to split the data? Of course, kindly just observe, dear friends, here we are making the X data and the Y data as towards the dependent and independent variable, and with that, yeah, we are just having our test size as 0.3, which it just specifies as like training data is 70% and 30% as testing data, and with that we are going to make use of it. And let me just have before the splitting and after the splitting, what is the shape of training and testing. So here X test, X train data, and Y test and Y train data, we just got it. Okay, now let me just build the model. So here building the model, yes, we are just going to use this sm.ols. Sm, of course, here kindly just observe, dear friends, this sm, that is what our main functionality, as I have already specified. Okay, so with that functionality, I am just going to apply OLS. So that OLS, okay, so we are just going to fit the model. So here you are fitting the model to your training data, and the output summary will provide an important statistics. What it just goes, yeah, it just going to show the R-squared value and adjusted. So kindly just have a view. Wow, this is what an observed one. So first of all, let me just have what is the R-squared. Yeah, we just get a 95%. So an R-squared value around 0.95, it just suggests an excellent fit. And towards, when coming towards this conditional number, kindly I just go, we are having huge number now. Okay, fine. So here, when on just going towards this condition number, of course, this statistic helps assess multicollinearity. So a condition number that significantly greater than 1000 indicates severe multicollinearity, so which can affect the stability and interpretability of the regression coefficient. And here in our case, yes, we have 6.16 e to the power of 19. That suggests a strong multicollinearity. is a concern, and you may want to investigate further. Yeah, we can just go further also. And one more thing, Durbin-Watson, the number, yes, of course, it also checks for auto correlation in the residual of the regression model, and here a very close, that is towards 2.0, and our result, it is 1.934. Okay, so here with this, yeah, it just suggests that there is a no auto correlation, indicating that the residual are independent and properly distributed. Okay, and rather than any other here, of course, as I have already specified, yeah, whether if it is here I have already given you, so whether it is less than 100, yeah, it is no multicollinearity, and if it is between 100 to 1000, there is a moderate multicollinearity, and if it is greater than 1000, of course, severe multicollinearity. That is what I have just given. And towards the same, here also I have just given you the information related to Durbin-Watson. So if it is 0 to 2, it is positive auto correlation, and if it is equal to 2, no correlation, and if it is greater than or 2 to 4, it is negative correlation. And towards our statistics, we just got 1.93, indicates no significant autocorrelation, which is a positive aspect of our model. Okay, and yes, after fitting the OLS model, the next step involves making prediction on the test set. So converting the predicted value back to their original scale and calculating the accuracy measure. So here we are just going to make it towards the linear regression, full prediction model. And yes, dear friends, we are just making use of that transformation further now. So here we are used with np.exp. Okay, so with that we are making the exponential part of our functionality. What here we just do is, yeah, the prediction which is equivalent to exponential of e to the power of the value. Okay, so that is what here it is given. And once done, let we calculate the accuracy measures. And towards this calculation of accuracy measures, yeah, dear friends, we need to compute the measures as like root mean square error, R squared and adjusted R squared. Okay, yeah, we are here to evaluate that. Okay, once done, let me just tabulate it. Finally, you can organize the result in a tabular manner. Okay, so receiving that which is better for visualization, and you can also use the function towards making this tabulation. Okay, and here we go with this. So this is what the linear regression, we are having a full model with log transformation of target value, and we had the regression model as RMSE value as 37,726 and R squared value and adjusted R squared value. And what is next? Of course, here we are not at end. We are going to have the same full module without log transformation of the target variable. Kindly just let me have a view onto the same. And kindly observe, dear friends, we have the same model, and without that log transformation, let me just build our model. And using that, which we split in the previous section, yes, of course we have done. So let I use the same thing, and we observe the R squared value. Okay, so here the value indication the post of the proportion of variance in this dependent variable, that is the property sale price. Here we just get it as 94%. That can be explained by that independent variable, and this R squared value of around 94% suggests that the model explains a significant portions of the variation in sale price. Let me just have the view of condition and Durbin value. So yes, condition here, yeah, it seems to be 6.16 and which suggests a severe multicollinearity. And back to this Durbin-Watson, it is 1.973, which suggests no significant autocorrelation. Okay, now yes dear friends, let me just apply it on towards the testing data to predict on the test set. And with that, and I have just named it to differentiate it as like no log transformation, and here with that functionality I'm just going to make it as a tabulation. Kindly just observe dear friends, here we have this tabulation without log, and observing on towards this RMSE value and this R-squared and adjusted, you are able to see that there is a severe multicollinearity indicated by the condition number, which should be addressed in further analysis, possibly by removing or combining correlated predictor. So upon reviewing the result, you will note that the linear regression model using this log of target variable is performing slightly better than the model without log transformation. So therefore you will continue with the model that uses the log transformation for further analysis. For what we are just going to do, yes, additionally we are just going to apply future engineering. The addition of new feature should ideally improve model for performance. So compare the result of this new model with the previous model to determine the effectiveness of your future engineering effort. And of course, dear friends, the future engineering, it is more important. It is crucial for improving model performance by creating new feature that encapsulate additional information or relationship in the data. And here, yeah, we are going to create a new total feature, that is as like a new or a total square feet, that is representing the total square feet area of the house by adding the area of first floor, second floor, ground floor and the basement of that house. So with having a new thing, add uponing all these variables, we are creating a new feature called total SF, total square feet. Okay, so that is what I have just given here, and kindly just see here on making this new total feature, new feature, we are just going to drop the existing this 4 feature. Okay, so let me just have a view onto this, and yes, let me have the total data, and let me have a functionality on towards getting towards the concatenation of this numerical and categorical variable. Nothing much more, dear friend, don't get confusion here. Here we are just making a new feature, and the whole thing we are just removing it, and we want to concatenate it into this. Now let me split that particular data, and we are just naming it as like a DF dummy, and that exact data we want to make it. And kindly just observe here, already we have used this log property, and I just want to make it towards the drop, and we want to extract it with the as like an y, that is the dependent variable. And with the splitting functionalities, I am not making much more difference towards any character, the same variables, one and only thing. And kindly just be aware what is the feature you are making use of, and same test size, that is 70/30, that is what applied here. Okay, I just execute this, and towards, yeah, same thing, 1015 is our X training data, and 436 is our testing data. Okay, now let me just fit our model here, and towards this fitting, let me just have the view. So on towards viewing, we have, so observe the dependent variable here, we just get it is log property sale price. So we are on towards the evaluation on log property sale price, which indicating our R squared as 95 percentage. Okay, so let me just have a view on towards the condition and reporting on. Yeah, condition it is 1200 and okay, it is more than 1.26 E. So here, of course, there is an multicollinearity and towards somewhat extra multicollinearity. Okay, and here it is Durbin-Watson, yes, 1.934, which is just to specify autocorrelation. So no significant autocorrelation is there. You can also have a view of skewness or kurtosis, okay, omnibus variables, okay, and more things are there. But when we just check on towards this regression, of course, we just check for this just assumptions of whether it is linearity, normality, autocorrelated, and multicollinearity. That is what we are just making use of it. So that alone here we just summarize it. Now let me move on towards the prediction value. Okay, so we are making it towards predicted, and kindly just observe, dear friends, this predicted sale. Here we just go with exponential, that is prediction sale price, which is equal to e to the power of predicted log price. So that is what here it is specifying, and applying, of course, we are going to compute the RMSE. So viewing on towards RMSE and tabulating it in such a manner, we just get 37,781, okay, which is just slightly the one higher than the log of transformation that we have done. And of course the R squared, it is slightly low, but what we just got that RMSE, it is also higher. Okay, now let we just make use of one more new feature which we can make. See, actually we are just checking for any new feature. We can just remodel it, and we just transform it, and we can improvise the performance. So here what we are just making it by using this building age and remodel age, we are just going to create the new created variables here. So whether it is year built, yeah, we are just making it as like a building age, and with the future of year remodel addition, we are just going to make it as like a remodel age. So let me just first of all let me just make use of our current year, getting our current data, and we want to evaluate it with the year built and year remodel added. Okay, so now we are going to have two new futures, and let we just apply that. And once on applying that, we are just removing the existing year built and year remodel addition. Okay, so I just remove that, and of course filtering all the categorical and numerical, so that we can create an encoding functionality onto the categorical here, and once done, we want to concatenate back. So this happened. So once done, dear friends, kindly just observe, we want to split that exact data, and here again towards the property sale, we are just making it with a log property sale price, and making it y towards that as like our dependent variable, and the same test sites here we applied. Okay, now let me just fit that model, and let me just observe what is the value. And of course the dependent variable log property sale price, we just get 95 percentage of R squared, and towards the conditional it is 1.28, and this Durbin-Watson, it is 1.93. And of course, dear friends, kindly just observe here what we have done towards the value. Yes, Of course, the approximation here we just get as 94% towards the log property sale price. And towards multicollinearity, of course, we have there is a severe multicollinearity is there and no significant autocorrelations. And towards this RMSE value and R squared and adjusted R squared. So first of all, let me just have an apply on towards this test, and let me predict the accuracy here, and measuring the accuracy, let me just tabulate it. Okay, so see here, dear friends, this is what the tabulated manner, and improvised RMSE. Okay, so once after rebuilding this, we have an improvised increase in RMSE, and yes, of course, the previous what we have the same R squared and adjusted or things also, but anyhow we have an improvised model with this new future building age and remodel. There is an increase in RMSE values. Okay, now what we are just going to, with this model, let we apply on towards this future selection. That is future selection. Yes, we are going to evaluate the variance inflation factor. Actually, this is very much essential tool in regression analysis to access the multicollinearity among independent variable. We have severe multicollinearity, and here of course we are going to know what is the exact purpose, and towards the purpose, how much the variance of the regression coefficient is increased due to collinearity, that is multicollinearity, we have to know. And we have to quantify this VIF, that is variance inflation factor, and with that let me just further provide, and to identify or to quantify the VIF, we have to have the formula as like 1 by 1 minus R squared. Okay, so that is the exact thing to evaluate. And of course, dear friends, we have already had an evaluation towards this model, and now we want to interpret of this VIF values. So kindly just have a note on towards this VIF values, and I just want to calculate it. And when on just making it towards calculation, kindly just observe here the columns which we are going to have it as towards the VIF factor, and this future I want to sort it out, and here observe it the values, and this exact VIF, if we are having the value when we just specify if it is 1, of course we have no multicollinearity, and if the exact value that is between 1 to 5, it seems to be as like a moderate correlation, and if it is greater than or 5, of course high collinearity, and if it is more than 10, of course we have few more than 10, of course that more than 10 it just specify as like severe multicollinearity, which suggests that the variable should likely to be excluded from the model. Okay, so that is what here we have, and which is the greater than highest, of course this total SF that has a higher, 1 second, yeah. Yes, the total SF, of course, that was we have created. Rather than that years sold, which it has 92. 92 is the one that has a higher future. Okay. Okay. Anyhow, let me just move on towards the other functionality. Okay. So kindly just observe, dear friend, this exact filtration, that is whichever we are going to have the value that is less than 10, we are going to apply accumulate that alone. So let me just update our data frame with VIF that is less than 10. And this one, yes, of course, the new data frame that you have created, which contains only the variable with the variance inflation factor less than 10, that is what going to happen here. And let I first of all execute it. And these are the factors which we have as VIFF value and which is less than 10. And what is next? Of course, let we create a model using this categorical variable and the numerical variable that don't have multicollinearity, that is VIF less than 10, and let we apply. And to same, dear friends, I'm just going to have the concatenation of that variable, and let we have the yes, here we have the property of that is the y data that is towards the dependent variable, and with the test data, let we just build the data. Okay, sorry, building the model, and what we observe here. So we observe 93% of R squared. So towards this 93%, what you are able to see, that is that which we are having it under log property sale. Okay, now let me just have a view on towards this condition. Okay, here kindly just observe the condition. Now it is increased. Now it is increased. So there is a severe multicollinearity. But towards one this Durbin-Watson, it is 1.943. Okay, 946. Okay, now let me just have the prediction and towards the exponential function, and let me compute the accuracy. Towards the tabulation, let me just observe. So this linear regression with VIF has the lowest RMSE. So that is what with among the above we have the lowest RMSE value. So which we conclude that this exact model which we have this new future can be used to predict the price of the house. So dear friends, even though here we have 93% of R squared and 91 of adjusted R squared, we have the lowest RMSE among these one. And dear friends, the project which we have discussed now, this underscores the importance of comprehensive approach to predictive modeling. Starting from the data understanding to rigorous future engineering and model evaluation. Through this process, we learn how to handle, of course, we just gone through skewed data and addressing this multicollinearity and refine models by introducing new features. So this framework is a robust guide for approaching any regression problem, helping to uncover insights and make accurate prediction. And dear friends, through this comprehensive work we have explored the entire process of building a predictive model. And the key takeaway I just want to specify, is the with a right tool and approaches, even complex data can be transformed into actionable knowledge. So thank you for watching, and I hope this inspires you to dive deeper into data analysis and machine learning in your own project. And I hope you like this video. If you find it so helpful, kindly just don't forget to hit the like button. And if you're not yet subscribed, kindly just subscribe the channel and turn on notifications so you don't miss any of my upcoming content. And if you have any doubts or any queries, kindly drop a comment below, and it would just give me an motivation to give or add upon a suggestion in for future topic. And as always, keep learning and stay curious. See you in next video, dear friends. Happy learning.